Hey everyone, welcome to this video for P8105, a course on data science. This is a quick video on tidytext, a package for analyzing and managing text data. I'm going to start by giving a quick introduction using slides, and after that I'm going to demonstrate the material in a screencast. Feel free to skip around to the parts of the video you find most useful. To get the most out of this, please do code along with me. All the material is available at p8105.com. There are links in the description below. Let's get started. All right, so we're going to talk about tidytext, which is this package for working with text data. And first, I want to be clear about what I mean by text data. What we're talking about here is not so much categorical data or factor variables or individual words or things like this. When I think about text data, really what we're talking about is written information. And you can think about this in a variety of ways. Sometimes it's whole sentences, sometimes it's paragraphs, sometimes it's chapters, sometimes it's books. This can come from a variety of sources. Maybe you're looking at tweets, maybe you've downloaded some, I don't know, doctor's notes, you've downloaded some other kind of information. But the idea is that the data that you're dealing with is complete text. It's not just individual words, at least not at the outset. The idea is that the text data that you're interested in is somehow some block of text. And this is going to be stored as a string. It's managed as a character variable in R, but really what you're focused on is trying to understand or do something useful with text. Now, one of the first things that comes out of this, though, is trying to figure out, given some block of text, what is the actual unit that you're interested in, right? So if you're thinking about like a tweet, what is the thing that you care about inside of that? What is the unit of observation that you're really interested in? And we're going to refer to this in the parlance of text analysis, or at least in tidytext, is thinking of those as the tokens, which is the meaningful unit of text, the sort of object that is interesting. Sometimes this is paragraphs, sometimes it's sentences, sometimes it's phrases. A lot of times, and what we're going to spend most of our time thinking about, is that the tokens that we're interested in, the meaningful unit of text, is going to be individual words. And so you might have like a sentence and you're interested in each of those individual words. Now, where tidytext comes from is the idea that once you've sort of identified what your tokens are going to be, you need to have a tidy way of analyzing that data set. So if you're sort of thinking of a data frame and it's got like tweet number 1 and then the full tweet and then tweet number 2 and then the full tweet, well, that's not really tidy, because inside of that tweet you've got individual words, and the individual words are actually the observations that you care about. And so this is sort of it's not exactly like wide, but it's close to wide, right? It's sort of thinking of having multiple observations that you care about all stored within the same row of a data set. And that's really not what you're interested in. So one of the things that you're going to do is unnest or make this from a row that contains a lot of observations to something that looks like tweet 1, first word, tweet 1, second word, tweet 1, third word, right? And then you get down to the second one and you get like tweet 2, first word, tweet 2, second word, and so on. And gosh, saying tweet an awful lot is just kind of a weird thing to do. But okay, so then you've done that. Let's just sort of assume, and we're going to see how that might work. Let's assume that you can get your data organized into what is more obviously a tidy format. Once you've done that, you still need to do some analysis. So one part of tidytext is just focused on reorganizing text into a tidy data structure that would be recognizable across a variety of like tidyverse kinds of packages. And then the next step is to do something useful with it, to do some analysis with it. And tidytext has some useful tools for that as well. One of the first things that you're going to do, especially if you're focusing on words as the unit of observation, words as the sort of unit that you care about, one of the first things that you're going to do is get rid of things that are common but not really helpful, right? So you can think of the and of and a whole bunch of like individual words that are going to be present in data sets but aren't really useful, right? So tidytext has a data set that is built in called stop words, and you're going to want to get rid of all of those stop words. After that, one of the things that you might do is get some idea about which words are used frequently in the remaining data set. And so you might sort of count word frequency across users, word frequency across individual tweets. You might just sort of look for what's going on. And very often this is using tools that you've seen elsewhere, right? If you've got a long list of words and you say this is user 1 and this is user 2, well, you might count up the number of words for user 1 and the number of words for user 2 using like a group by and summarize, or a count by group by and count, something like this, right? So that's pretty straightforward. The next thing, though, is that often when you are dealing with text, you have different numbers of observation in the groups that you're interested in comparing. So one of the things that people will do very often, rather than just counting up the total number of words, is compute something like a relative frequency, right? If you have like two people who tweet and one of them tweets all the time and one of them tweets not very often, the word counts are going to be very different, and that difference in word counts is not going to be as informative as it would be if you just sort of looked at how frequently within this user a word appeared and how frequently within this user a word appeared. So one way that you can make that comparison is doing something that's kind of like an odds ratio, right? And I'm putting here, this is absolutely an approximation in a couple of different ways, but the approximation that you might use here to get something like a comparison of the frequency is to say, how often does this specific word show up in this user's tweets? I'm sticking with that example. How often does this word show up divided by the total number of words that person does as a measure of the frequency with which that word appears, right? And you can add 1 to both of those. One of the reasons that you do this is if a word count doesn't appear at all, you can end up in a weird situation where you've got a division by 0 thing. So just like doing word counts plus 1 gives you a bit of an approximation to something like an odds ratio, but it usually works out just fine. And then you want to compare that to a reference category, some other user. You want to know, does this person use that word more often or less often in a relative sense? Is it more common among all of the words that this person uses to see this one in particular compared to that same word for a different user? And so again, you're going to compute like a frequency here and a frequency here, and then do something like a log ratio of those two things. And again, we're not exactly computing an odds ratio. We're not like doing an odds in the top and then an odds in the bottom. We're doing something like that though. And this will give us some idea about a ratio of the frequency with which two words are going to be used, or one word is going to be used by two users. Okay, so that's a useful kind of an analysis to do because it gives you some idea about like which words are more common in this group and which words are more common in this group. Another thing that you might do that changes the direction a little bit is to think about what is the overall tone of messages that are being posted, or what is the overall tone of words that have been used. And so here, one of the things that you can do is count sentiments, right? And this is sort of a weird thing to do, but if you sort of think about all of the words in a sentence, you could go through and categorize them as either positive sentiment or negative sentiment or neutral sentiment. And so things like happy is a happy word and sad is a sad word. And people have constructed large lexicons that say, here is a list of words and here is their sentiment, either positive or negative. And so given this collection of words and this collection of sentiments, if you sort of bring these sentiments into your data set using a join, well, then you can go tweet by tweet or user by user and count up, are these more frequently positive or more frequently negative, and get some idea about the overall tone, the overall sentiment that is conveyed either by individual tweets or by collection of tweets or by whatever other text it is you're interested in. And so those are, I think, the most common kinds of analyses that people end up doing with text is relative frequencies and then sentiments, and that's after you have spent some amount of time just sort of looking at what words appear with what frequency and so on. So that's what we're going to try to do. We're not going to look at tweets. We are going to look at something else, which I'm really excited about, and hopefully this will be an interesting example. And that's what we're going to do now. So we're going to get started. Thanks. Awesome. So we're gonna do some text analysis here, and I've got the tidytext GitHub document R Markdown. I'm loading the tidyverse. I'm loading tidytext. And I'm loading rvist. And I've already gone ahead and both run this code chunk and also knitted this document once. You'll notice here that I'm caching this code chunk. The reason is that the data that we're going to use are the reviews of Napoleon Dynamite that's coming back. We're using the reviews of Napoleon Dynamite, and I've gone through and from Amazon taken 100 pages of text or 100 pages of reviews, and then from those extracted out using code that we've seen in the past, the review title, the review stars, and the review text. And I'm caching this because I don't want to like go to Amazon 100 times every time I knit this document. They're going to get angry at me, and I don't want to wait around that long. So I'm caching this output so that as long as I don't change anything, I will have that same data set in the future. This is maybe not a perfect thing to do, if I'm being honest, because if I ran this a week from now, I wouldn't get any new reviews. So this is I don't know, it's useful for now, but if you are really concerned about staying all the way up to date, you might have to do something different. We're not going to be that concerned about this. So I've run this and I've knitted the document so that I can do this again. And let's just double check that it sort of works the way that I want to. I've got 100 pages with 10 reviews each. I've got 1,000 reviews, and I've got title, which is text, but it's text that we're not going to worry so much about. But we've got things like the title is classic, fun for all ages, 5 stars. I like this movie. It is not a deep, only watch this if you like good. And then a 1-star review, stupid movie, fantastic. All right. Okay. So that's what we're going to try to analyze. And what we're going to focus on actually is the data here in the text of the review. We're going to go through and we're going to see like what words get used in the text of reviews, whether or not there is a difference in the kinds of words that get used in 5-star reviews and 1-star reviews. We're going to count up things like the sentiment of the text inside of these, and we'll see things like stupid is probably a negative word, but like is probably a positive word, and so we'll try to count these things up as well. That's the data that we're going to be taking a look at. So fantastic. So we've read in our data. And what we're going to do, again, is focus on things inside of text. So let's do some tidy text stuff. The first thing that we're going to try to do is recognize that the text here, if this is what we're interested in, and we're going to be focusing on individual words inside of the reviews, well, our data isn't tidy yet. What we have here is one row that's got all of these words in it, and really what I would like to have is something that's like review number 1, word 1, and review number 2 and word 2, and review number 3 and word 3, and so on. And I guess one thing that's different here, I am keeping track of individual review numbers so that when I unnest these things, I know which review each word came from. So that's the first thing that we're going to do is get the individual words. So I'm going from Dynamite Reviews to Dynamite words. And the way that I'm going to do this is taking Dynamite Reviews, and I'm not even going to try to type that again, it's a hard one. What I'm going to get next is using the tidy text function, I'm going to unnest tokens, and here I need to tell it what is the data frame first, what is the token that I'm interested in, and then what is the thing that I would like to unnest. So here I'm going to unnest word, that's what I'm trying to produce is the output, and the input that I'm trying to operate on is the text column. So if I unnest these, what do I end up with? So now I've got page 1, review 1. I'm still keeping these URLs. Maybe I should get rid of these. Let me just select minus URLs, just because those are going to take up a lot of space. Okay. So what I get is page 1, review 1. I'm keeping the title and I'm keeping the stars. That's fine. But now I've got word. The first word is going to be I. Second word is like. Third word is this. Fourth word is movie. It is not deep, right? So I've just gone through that individual review and extracted out individual words, gotten rid of punctuation, gotten rid of other things. It's sort of all lowercase. Everything has been sort of made tidy in some sense, and that's sort of what we're left with. So great. The first step here is to say, all right, can I get the words that I need to have? And the answer is yes. So I've gone from 1,000 rows. Now I've got 16,000 rows, and I've got a column for words that have all of the words in the data set that I'm interested in. So that's pretty great. And what I'm going to do next is, like at this point, I feel like a lot of what happens now is usual tidyverse stuff, just operating on text data in a way that you might not sort of think to do immediately. Well, I guess actually before that, let me remove unnecessary words. I was going to say boring, unnecessary. I'm going to say boring because I'm not sure I can spell unnecessary right this minute. Remove boring words. So what I'm going to do is take the Dynamite words, and I am going to update these using Dynamite words. using an anti-join of dynamite words and what are called stop words. And before I do this anti-join, let me just sort of take a look at what's here. So I have in stop words, and this is built into tidytext. There is a lexicon and there is a list of words that are just not helpful, right? So anytime you see the word about or a or able or all or allows, right? There are some words in here that you might think maybe we do want to keep. I don't know, maybe beforehand is a word that you do want to keep. In any case, all of these words are viewed as stop words that are basically filler between other pieces of text that are actually important. You probably don't need to keep because everywhere unless you wanted to know how often somebody says because. And there's a lot of these. The idea is we want to get rid of all of these. And so, or get rid of all of the instances with which those appear inside of our dynamite words data set. So this anti-join is going to say, keep everything in this data set as long as it doesn't appear in this data set. And we're doing this based on the word column in both of these. So this anti-join now, let's take a look at what we have. That has removed nearly 10,000 rows, right? And so it's removed things like, actually in this case it removed things like, but also removed like, I like this movie, it is not deep, right? So it's getting rid of a lot of stuff, but it's keeping things like movie and deep and thinker and movie again, clean, watch, Pedro, and so on, right? Okay, so that's what we're interested in. And so now what we're getting into is usual tidyverse stuff. Usual tidyverse stuff. And what I mean by that is, well, maybe we just want to know how often words appear, right? So let's take a look at dynamite words, and let's just count words. Sorry, count word. And it says the word here, and so word is a little bit imperfect if I'm being honest. The word here, 1 appears 7 times, 1.5 appears 1 time, 10 appears 9 times. That might be like 10 out of 10 or something like that. 100 appears 4 times, and you know, there are reasons why this might work, but let's do, I think we can sort equals true will give us the words counted and in order. So the most common word among all of these reviews, not surprising, is movie. It appears 541 times. Funny appears a lot. Love appears a lot. Classic movie. Hilarious. Movies appears pretty often. Favorite. So there are a lot of words here that seem reasonable, seem like things that would show up in the context of a collection of movie reviews on Amazon. And that's, again, like we've just taken a data set and counted up the number of words, and we can do some other things too, right? So we could just sort of filter, let's take the top 10 words, and this is mostly sort of prep for things that we're going to see later. I could then put these in order. I'm going to say that word is factor reorder word, and I'm ordering this in the order that they appear in N here. So a couple of ways that I might do this. And then I'm going to make a plot where I could do like a ggplot, and let's say that the x-axis is word and the y-axis is N, and I'm going to do, let's do geom bar. Let me just check. What is geom bar? Oh, I need plus. Sorry. I need to tell it maybe the stat is identity. Bar plots are always a little bit strange. Great. So there's my bar plot, right? And it says favorite appears this many times, hilarious, Napoleon watch, and so on. What else could we do? We could like fill this with a different color if we wanted to. We could set an alpha level. I'm going to do chord flip, not flop, chord flip. And the reason I'm doing this is that often this is for how, you know, I'm not real sure why, but this is one of the formats for plots like this that shows up pretty often, right? Where you're counting like how often do you see the word movie, and there's a bar plot that's sort of on its side. Great, awesome, fantastic. So that actually, I mean, like this is if you take a step back and think about it, that actually is pretty neat. What we've been able to do is, given all 1,000 reviews of Napoleon Dynamite, we've been able to extract the words that we think are informative and then see which of these words are the most popular. So I'm going to go ahead and knit this just because it seems like a reasonable time to. And commit. What are we doing here? Tidy words and count them. All right, so the next thing that we're going to do is, like I said, there's sort of two common analyses when you're doing this kind of text data, and we're going to take a quick look at both of those. The first is to see which words appear more often in, say, one batch of text in comparison to another batch of text. That's what we're going to start with. And then the other one is to look at overall sentiments that go along with the reviews that we're interested in. So let's get started. We're gonna do a comparison. Compare across groups. And again, like, this is one of those things where a lot of the stuff that we're going to do is, at this point, mostly just normal tidyverse stuff, right? The motivation for it is definitely coming from text data, but the implementation that we're going to use is really just going to be like, we need to do some data manipulation, right? And it's sometimes tedious data manipulation, and it's sometimes sort of hard to know why exactly we're doing a particular thing, but we're going to walk through that, and that's what we're trying to do. So the groups I want to compare are 1-star and 5-star reviews. So I want to know, in particular, what words show up more frequently in 5-star reviews and what words show up more frequently in 1-star reviews. And so one thing that we might do is, like, let's count words in these groups. Let's count words in these groups. So again, doing tidyverse stuff, I'm going to take the Dynamite words data set, and I'm going to look only at these two groups. Filter stars needs to be in either 1 or 5. Those are the two options. So I've got 5,000 words that come from 1-star reviews and 5,000 words that come from 5-star reviews. Okay, and I'm going to group by stars. Doesn't seem to do anything, but the reason I'm doing this is so that now I can count word, and that's going to give me, in each of the two groups, it's going to count up the number of times that this appears and this appears and so on. 80, I don't, why did 80 appear twice? I don't know. We could go look for 80, but we're going to sort of skip past that. And so now what I'm going to use is a similar function that I had seen before. I'm going to use that top in function, and for now I'm just going to look at the top 5 words. We can do something a little bit more formal later if we want to, but the point here is to just print out what are the most common words. And these aren't like ordered in terms of anything. I haven't put them in order here. I'm just taking the top 5 words in 5-star reviews, and it looks like maybe there's a tie here, and then the top 5 words in 5-star reviews. And so you see things like movie appears here and movie appears here. That makes sense. Time appears in both of these. But things like in 1-star reviews, you see bad and dumb, and here you see classic and funny and love. Now, this is maybe a useful comparison, but again, there are probably a lot more words in 1-star review, or sorry, in 5-star reviews than there are in 1-star reviews. And so here, and I guess, like, why do I think that's true? We can just sort of count up the number of words in each of those. So let's just do, like, here, what do I want to do? Like, summarize. And I just want to know everything that's in here. No, that's not what I want to do. I want to group by stars and then summarize, just count up everything. So I have 600 words that are coming from 1-star reviews and 4,000 words that are coming from 5-star reviews. So when you see things like movie appearing 50 times here and 400 times here, maybe people say movie more often in 5-star reviews, but maybe there's just a lot more words in 5-star reviews, right? And so what we're really interested in is, does dumb show up a lot here, and does it show up a lot more often relative to the total number of words than it would show up in 5-star reviews. And so that's that's what motivates this sort of odds ratio-esque kind of a thing, where again we now need an odds ratio, and I'm putting odds ratio in quotes because I'm doing, I think, 2 levels of approximation here. But I'll talk through what those are and sort of where we want to do, right? But the basic idea that I want to get is I want to divide 50 here by the total number of words, 648. And I want to divide 430 here by the total number of words. And I want to do that for every single word that appears in any of these reviews. And then I want to see which words appear more frequently in 1-star reviews and which words appear more frequently in 5-star reviews. And so this is one of those places where we're going to be using tidyverse stuff, right? There's no new tools that we're going to be using to do this, but the data manipulation process is a little bit weird and worth talking through. So I'm going to define a word ratios data set, and the way that I'm going to do this is going to start, let's see, I think I can take dynamite review, no, filter, group by, stars, count, word. I think all of this stuff is going to stay the same, right? So now I've got how many times does this appear, how many times does this appear, how many times does this appear, and I'm gonna focus on words that get used at least somewhat frequently here. And so what I'm gonna do, actually I've done, what have I done? Dynamite. I'm gonna not group by stars yet. I'm gonna count word and stars, sorry. And the reason is I wanna know how often does this word appear in 5-star reviews and how often does it appear in 1-star reviews. So I can't just count up the number of words. So this, all right, so I'm doing a little bit better here. Okay, and what I want to end up with is how often does this word appear in 5-star reviews and how often does it appear in 1-star reviews. And I'm going to focus only on words that appear at least 5 times. And that's an arbitrary threshold. The reason that I'm focusing on words that appear at least 5 times is so that when I start computing something like an odds ratio, I don't get really thrown off by a word that appears 2 times in the 5-star reviews and 0 times in the 1-star reviews. I want whatever the things that appear differentially, I want to know that they have appeared at least some reasonable amount of times. So what I'm going to do here is filter, I think I'm going to do sum of n greater than or equal to 5. And when I do this grouping, what am I going to do? I'm going to group by word. So I'm doing sort of a lot of stuff here, but basically what I'm saying is look inside of this word and then count up how many times it appears total. I'm trying to see if there's one. All right, so this is a useful example. So 10 appears in both 1-star reviews and in 5-star reviews, and what I want to know is the sum of those 2 numbers, and I want that word to appear at least 5 times. So here, this is probably going to go away because it only appears 3 times. This is going away because it only appears once. This appears a total of 8 times across all of my reviews, 1-star and 5-star. So when I take that sum, it's going to be greater than 5, and I'm going to keep 10 for whatever reason, right? I'm keeping 10. I don't know why people are putting 10 in their Amazon reviews, but we're keeping it as a word. So let me try this. Okay, so let's sort of again take a look at what I have here. The word 10 appears 1 time in 5-star reviews and 7 times in 1 time in 1-star reviews, 7 times in 5-star reviews. That's a total of 8, and we're keeping it. 15 appears once in a 1-star review and 4 times in a 5-star review. Total times it appears is more than 5, more than or equal to 5, and we're keeping it. Absolutely actors 2 appears 5 times in 5-star reviews and no times in 1-star reviews. Okay, fine. All right, so these are sort of the candidate words and the counts that we have, and I'm interested in having these. I've got both 1-star reviews and 5-star reviews, and if I don't have a 1-star review, it just doesn't show up at all, right? So this is where things are going to start getting a little bit strange. What I'm going to do now is I'm going to ungroup first, because I don't want to be dealing with groups anymore at this point. Ungroup by word. And what I'd like to have is for each word, I want to know the count, how many times it appears in 1-star reviews, and then how many times it appears in 5-star reviews. So what I'm doing now is a little bit untidying things, right? What I'm going to have is a row for 10, and it's going to say how many times do I see this in a 1-star review and how many times do I see this in a 5-star review. So I'm doing a little bit of untidying here, and the reason that I'm doing that is so that then I can compute the ratios that I'm interested in, so that I can look at this word, divide by the total number of words, this word, divide by the total number of words, and do that for 1-star reviews and then 5-star reviews, and get like a ratio column for 1-star reviews and a frequency column for 1-star reviews and a frequency column for 5-star reviews, and then divide those things, right? Like we're working through what this data needs to look like. So the first step here again is a little bit of untidying, pivot wider, and I'm taking names from stars and values from n, and I'm going to do names. Prefix is let's say stars underscore, and so what that's going to do is give me stars underscore 1 and stars underscore 5 as my column names. And last thing that I'm going to do is fill in, rather than letting pivot wider take something that doesn't exist here and treat it as NA, I'm going to fill any observation that doesn't exist in this data set. We're going to call that a 0 because that word has been counted 0 times. So let's see what this does. Ungroup I think is the only thing I need there. That's not working. Components of blank 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 were not used. Oh, sorry, fill I think is values fill. All right, so I've got a reorganized data set here. The word 10 appears 1 time in 1-star reviews and 7 times in 5-star reviews. And what I want to do next is calculate something like an odds. And when I say the odds, I mean the probability of this word appearing out of all of the words that appear in 5-star reviews compared to the probability of that word not occurring, right? So I want to compute something like 7 divided by the total number of words in 5-star reviews and 4 divided by the total number of words in 5-star reviews. And I'm gonna call this an odds, but it is at least a little bit of an approximation. And so what I'm gonna do here is mutate, and let's do stars 1 odds. And the way that I'm gonna do this is say, first let's look at stars 1. I'm going to add 1 here. Again, we sort of don't want to end up with a case where we've got a bunch of zeros hanging around, and so this +1 business is going to be a bit of an offset, where again this is not exactly the probability or the odds of something appearing, but it's pretty close. And then I'm going to divide this by, again, the sum of stars 1, and I'm going to add 1 here. And the adding 1 here is sort of to mimic the adding 1 here. And I'm going to stop here. If I was really computing an odds, I would want to compute something like 1 minus this and then divide by 1 minus that thing. But these values are all going to be pretty small, and dividing by 1 minus these is going to be close to dividing by 1. So we're going to leave that out, right? So I'm saying odds here, but recognize that it's not exactly that. And if I just stop here, let me just sort of double check that I'm getting something. So the odds of this word appearing out of all of the words that appear in 1-star reviews is 0.00783. Amazon appears 0.02, right? Another way of thinking of this is like the frequency of words, the frequency with which Amazon appears as a word among all of the words that might appear here, okay? And so we're going to do the same thing now for 5-star reviews, stars 5, okay, and we get all of that. So then you can start to see whether or not things appear differentially. So 15, for whatever reason, seems to appear more often among 1-star than 5-star. Looks like Amazon is appearing quite a bit more in 1-star than in 5-star. Okay, and instead of just like running through all 148 rows here, we're going to calculate a log odds ratio. Again, odds used sort of loosely here. That's going to be the log of, let's do stars 5 odds divided by stars 1 odds. And so what we're going to be looking at here is high values of this means that something appears quite a bit more often in 5 stars, and low values mean that something appears more often in 1 star. So let's just double check that this works with are any of these in a different direction? Nope, these are all negative. So again, things that are negative means that this appears more often in 1 star odds and less often in 5 star odds. And if we saw some positive values, that would indicate that something appears more. Positive values would indicate that something appears more often in 5 star reviews. All right, so this is already like a pretty long code chunk, and I'm gonna like pause right there and move on to another one. So can we do something useful with this? The short answer is yeah, we can. And what we're going to try to do is actually something that looks a little bit like this. We're going to go through and we're going to try to extract the usual tidyverse stuff. Sorry, something that's a little bit closer. Where did I put it? A little bit closer to this, where what we're going to be interested in is how often or can we get the biggest odds ratios in the 1 star groups and in the 5 star groups, and sort of see what that looks like. So again, this is going to be usual tidyverse stuff. It's just sort of like a hassle to do. So what we're going to take is the word ratios, and what I'm going to try to do is identify things that are favoring 1 star reviews versus 5 star reviews, and vice versa. So the first thing that I'm going to get is a positive log odds ratio, and that's going to be, I'll just use if else, log odds ratio is greater than 0. I'll say that this is 5 star, happens more frequently than 1 star, right? And otherwise 1 star is more frequent than 5 star. So let me just check that this has done something. That didn't even work. Argument yes is missing. Oh, if else maybe here. Okay. I could probably use case when here. That'd be a nice way to do it. Anyways, what this is saying is that the word 10 appears more frequently in 1 star than in 5 star. And if we saw a positive one of these, let's just view real quick so that we know that it exists. Here, awesome appears more often in 5 star than in 1 star videos. Or sorry, 1 star reviews. Okay, great. And now what we're going to try to do is plot this, right? So I've got this long list, and now what I want to be able to do is plot things. So similar to what we had seen previously, I'm going to group by positive log odds ratio. And what I'm going to take next is the top n. I'll save the top 10 of these. But the top 10 for positive are going to be large value, and the top 10 for negative are going to be things that are close to 0. I really want things that are sort of out in the extreme. So one of the things that's nice about this top end function is that you can give it some operation that you want to work with. So I'm going to take the absolute value of log odds ratio. And so what this is going to give me is something that looks like this, the sort of most extreme values in each of these. So now I've got awesome appears an awful lot in 5 star reviews compared to 1 stars. Bad and boring appear pretty often in 1 star reviews compared to 5 star reviews. So we're getting results that seem about right here, and we're going to try to make a plot that shows these. So I'm going to ungroup because unless you need groups, it's good to get rid of those. I'm going to put words, mutate word is same thing I had done before, factor, reorder word, and I'm going to put these in order of log odds ratio, and then so this should, I could probably print these in order of log odds ratio, but what I'm going to do next is make a plot. So let's do a similar plot that we had done before. Let's do on the x-axis is word, and on the y-axis is log odds ratio. And let's do the fill is positive log odds ratio. All right, and then we're going to do geom bar, and I think we have to do stat equals identity. Identity. See if this works. I always forget. Okay. All right, and I'm going to do the same thing where I do a chord flip and run all this. So now what we get is the word, and we have, we could change this to be a little bit more informative, but these are all words that appear more frequently in 1 star than 5 star, and these are all words that appear more frequently in 5 stars. Classic, times, dynamite, Pedro, loved, awesome, hilarious, funny. That all seems reasonable. People, I guess, did not like Blu-ray. That's weird. But dumb, paid money, bad, boring. These are all words that show up more frequently in 1 star reviews than in 5 star reviews. And again, that seems to be about right. So great. I feel like one of the things that is challenging about this is not so much, well, I mean, there's a lot of like real finicky bits of the code that we're trying to write to do the kind of text analysis that we might be interested in. None of this stuff is, I think, like we're not using substantially new tidyverse tools, but we're sort of having to be real careful about how we use them and understand that, to get to something that computes a log odds ratio, you have to like count some things and then ungroup and then pivot and then calculate one thing and then finally get the quantity that you're interested in. And then after that, like keeping track of everything that you need to have just to write this little bit of code. It's not so much that the code itself is hard, but the thought process and getting this to work is often not super straightforward. But that's the kind of thing that happens in this sort of text analysis. And what we're going to do next is what we're going to commit first. So this is compare groups. What we're going to do next is a quick sentiment analysis. All right, so what do I mean by sentiment analysis? We're going to look through all the words that we have in these dynamite reviews, and we're going to look for ones that are positive, and we're going to look for others that are negative. And then we're going to try, given those, we're going to see which reviews have the most positive net score and which reviews have the most negative net score by looking at positive word, negative word, and counting those up and sort of taking the difference between them. If you see 8 positive words and 3 negative words, you're going to get an overall score of 5. And if the situation is reversed, you get an overall score of -5. And we're going to see what did the overall sentiments look like here. So we need to load a sentiment lexicon. And the one that we're going to use is the Bing sentiments. Is get sentiments. There are a variety here. You can get, I'm sorry, it just sort of went away. You can get like Bing and something else. And we're getting the Bing sentiments. That's one that is relatively widely accepted. It is not Bing, the search engine. This is developed, I think, by Bing Liu. And let's take a look. So we've got a lot of words here, nearly 7,000 words. Two faces is a negative, abnormal is negative, abolish is negative, abominable is negative, abominate is negative. We got a lot of words here. Not all of these, well, I think this is one specific categorization, and it's not always going to be the case that abrupt is actually a negative word. It's not always going to be, I would imagine it's mostly going to be the case that accolade is a positive word, but maybe not, right? There are a lot of things in here that are subjective, maybe, and it's helpful to have these kinds of lexicons. It's helpful to have things that are well established, but there's some things here that you might in other kinds of analyses disagree with. We're not going to go into that bit of things. We're just going to say, okay, thanks for the sentiments. We're going to use that and count up what's going on here. So I'm going to get sentiments. I'm having a real hard time spelling today. Sentiments for Dynamite reviews. Okay, so I'm gonna create a data set for this, Dynamite sentiments. And the way I'm gonna do this is start with the words, and I'm gonna bring the inner join. Let me try a left join here. I'm going to bring into Dynamite words. I don't like piping here. I'm going to bring into the Dynamite words the Bing sentiments. Let me just check what this does. So let me see. I've got. Oh, you're right. No, I am right. I want an inner join here because I want only things that are overlapping in the words that I have here and the sentiment that goes along with it. So right now I'm like, there's no sentiment that goes along with movie. That's not positive or negative. There's no sentiment that goes along with deep or wacky, right? So some of these I'm not real sure that I agree with the sentiment, but fine. So we're going to use an inner join instead, and what that's going to give us is the words that appear here and here. We're going to have the sentiment that goes along with that. So clean and fun are positive, hate is negative, amazed, stupid is negative, amazed is positive, greatness is positive. And we've got 1,500 words that have been categorized in this way. Not every review has some word that has a positive or negative sentiment in it, so we're getting review 2, 3, 4, 5, so on. Okay. I'm just seeing like review one big yawn. The only word that we have right now is stupid, and that's a 1-star review, so like they are succinct and on point. I like that. Good for them. All right, so what we need to do now is let's count up the positive and negative sentiments inside of each of these reviews. So I'm going to count inside of review number. I want to count sentiment. And what this gives me is nothing yet, because it needs to be sentiment, not sentiments. What this is giving me is here I've got in review number 2, I have 2 positive sentiments and no negative sentiments. In review 3, I have 1 negative and 3 positives. And so what I want to be able to do is for each review, take the difference between positive and negative sentiments. So again, this is going to be like a data organization thing. So we're going to do pivot wider. And what we're pivoting wider here, we want names from sentiment, and we want values from n, and we want to fill values fill 0. Okay. See what this does. All right, and so now we're going to add a column for overall sentiment. Call this review sentiment maybe. Is positive minus negative. And I think I can do that all on one line because I'm not doing anything else. And let me just check. So what I really want to have at the end of this, I don't care about positive and negative. I guess we could keep it, but I'm gonna get rid of those 2 things. So I'm gonna select review number and review sentiment, and that's going to be our Dynamite sentiments. A lot of work to get these sentiments, but I've got review 2 got a positive 2, review 5 got a -1, 11 and 13 got -1s. And so the goal now is to do a couple of things. What we're going to try to do is take, we are going to start with the data set where we've got sentiments, and we're going to combine that with our overall data frame. And at this point, I'm really only interested in reviews that actually have sentiments along with those. So combine with full data. When I say combined with full data, I'm not, we're going to sort of go back to like that original data set that we had that's got review number, stars, review text, review title, things like this. Not one of the tidy text versions of this data set. I just sort of want to see what's going on with the star ratings and things like this. So I'm going to say, I'm even going to overwrite. I'm going to take dynamite sentiments, and I'm going to left join into dynamite sentiments the overall reviews. So what I get here is, again, maybe I'll select out URLs. So what I get is review number 2 had a sentiment to, the title was Fun for All Ages, it's 5-star, only watch this if you like good, clean, American something, stupid movie, again, I think my favorite review so far. We love this product, it came in a timely manner. All right. Okay, so with this sentiment data set, we can start doing usual kinds of plot things. And so I'm just going to make like one quick plot that shows what this looks like. So I'm going to take dynamite sentiments now, and what I want to make is sort of that same kind of a bar chart that we have seen elsewhere. And I'm not going to do the chord flip business. What I'm going to try to do is just show like a bar plot of sentiments. And then, sorry, I want a bar plot that's got like reviews on this axis, and it's got sentiments showing positive this way and negative this way. And I want to start with the highest sentiments and end with the lowest sentiments. And so this is mostly going to be about putting the review in some kind of an order in that way. So what I'm going to do here is first, I'm going to take review number, and I'm going to make that a factor variable. And then the next thing that I'm going to do is, now that that's a factor, I'm going to put it in the order that I want it to be in. So factor reorder. And the order that I want to put this in is the review sentiment. Okay, we'll try this and sort of see how it looks. And now I'm going to make a plot, G plot. And on the x-axis, I'm going to put this review number. And on the y-axis, I'm going to put the review sentiment. And let's just like see if this has done anything. So geom bar with stat equals identity. And I know well, this is going to be ugly, but we're going to try it and see if anything works, and then we'll clean it up afterwards. All right, so review number here now is a little bit meaningless. And what I've got is review sentiment over here going from the most negative to the most positive review. And so what I'm going to do to like clean this up a little bit is plot remove x-axis labels. Yep, copy and paste all of this. Seems right. The next thing that I'm going to do, I want these bars. So right now I am not including anything that has anything to do with the star information. So what I'm going to do here is fill these bars with the number of stars that a review got. And this is sort of bothering me. Okay. So let's try again. All right, so this is sort of a strange plot, but what this is showing is the review sentiments over here colored by stars. The most negative reviews are 1 star and 2 star. The things that have the negative sentiments, these look like they are actually negative sentiments. And the things that are mostly positive are again mostly positive, with 5 stars and 4 stars mixed around. You can sort of tell this isn't always perfect. You get some 5-star reviews that have an overall sentiment of -4, and that might be the sort of thing that would be interesting to dig into a little bit and try to understand what's going on. But basically this is a way of saying, does sentiment, generally speaking, match up with star rating? And for the most part, yes it does. And then the last thing that we're going to do is just sort of double check. Can we look at positive and negative reviews. Right, so you could like dig in and try to see which of these reviews is both negative but has a high rating, and maybe that's a problem with the sentiment lexicon that we're using. Maybe it's something else, but something that you might do here is, let's just look at Dynamite sentiments, and we are going to filter the review sentiment is whatever the maximum sentiment is, max of review sentiment. And let me pull the text here. So this is sort of interesting. Love, 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 love. We watched this twice a week and even had a Napoleon Dynamite party complete with corn dogs and tater tots. Fun. So this has a very positive review, probably because it has said a positive word 5 times in a row, and fun is probably a positive word as well. I don't know if there's anything in here that would be negative. I think there are 2 reviews that are tied for the worst review. And these are long. Starts off boring, but then the jokes start pouring in. So this is probably somewhere over here. There's like a 3 or 4 star review that has somehow gotten a very negative review. That's probably this one. And then the next one, let me start by openly admitting that I am an 80s throwback. This movie puts the duh in dumb. I love it. Man, people really put a lot of effort into their Amazon reviews, and I think that is a real service to the world. So couldn't miss out on the sheer stupidity of it all. All right, so that's where we're going to end things. I guess the last comment that I have about this is that there are a lot of real limitations to the sentiment analysis that we're doing, and a lot of the other things that we're doing also, right? We are sort of already going to be missing out. If something says this is not dumb, you would think like, well, that's, probably a positive sentiment, and the way that we're analyzing things misses all of that kind of nuance, right? So this is a little bit limiting in the way that you're able to actually analyze this text data. That said, you can get some really interesting information out of doing this kind of a thing, and depending on the data that you're interested in, especially doing the group level comparisons and sometimes doing these sentiment analyses can be a useful and interesting thing to do. So that's where we're going to end things. I'll knit and commit, but other than that, I think we're done for now. So thanks very much for paying attention.